Well, hello everyone. This is KP, the Math G here. Delighted to give you another AP Calculus problem. A lot of times I've been given AP Calculus problems from, from the last one I did, 2026, and it was a free response question. This one is actually a multiple choice question. I don't know what year that was given, but it is by this book right here. It is page 83, number 102. I'm not going to take credit for it, but this is a really good problem. 320 AP Calculus AB problems, arranged by topic and difficulty level by Dr. Steve Warner. And so they have 5 levels. I don't know what level this is, but it is something that we need to be aware of. Let me give you a quick review before we proceed into this. This may be a pretty good long video, so I'm hoping it's not too awfully long, but it's going to be a little bit of explanation here. So let me try to be brief. I will try my best to be very brief here in presenting this lesson. So let's go ahead and get started. So it says the acceleration A at t is equal to 3 minus 2t. This is no doubt uniform motion, and probably uniform motion in a straight line. It says if the velocity is 10, okay, at t equals 1. In other words, what they're saying is if v at 1 is equal to 10. Alright, so that's what they're really saying. At t equals 1, whatever, minutes, second, probably seconds, okay, and it's equal to 10 meters or feet per second, meters per second, whatever. And if s at t, which is the distance from the origin at time t, what is s at 5 minus s at 1? So we've got 3 things to look at. First of all, acceleration. We have the acceleration problem right here. What we want to do is we want to get to velocity, which means we got to get a velocity equation. Eventually, we want to get to distance. All right? And that's what we're really shooting for, distance s. Okay? So, yeah. So that's what we're doing there. Sometimes this is referred to as a position equation, okay, or a position function. All right, and also got to remember it is from the origin. It's not beginning at, say, 5. We'd have to include that, 5 feet, 5 meters, whatever that is, but it is at the origin 0. So 0, 0. So this is what this is, the velocity. This part right here refers to this here. And then what is s at 5 minus s at 1? A lot of work is involved. So what do we do? Well, do we take a derivative? Do we take an antiderivative? Oh my, what? Well, needless to say, we're going from acceleration to distance. So let me just kind of give you a little idea. From A to B, if we're doing a definite interval from A to B, A at t dt is going to be v at t. If I take that derivative, or antiderivative, from A to B, v at t dt, that is going to give me s at t. Alright, and that's really our goal, is to get to that. We want to get to s at A minus s at B. And that's what we're doing. S at 5 minus S at 1 right there. Alright, so let's take a look at what we're doing here. On the first one, we don't have a definite integral because we don't know what we're going from where to where. We have no idea. On the second one, we are going from 1 to 5. So that gives you an idea. So just keep in mind that when you're going from acceleration to velocity to distance, we're taking the antiderivative or a definite integral. Okay. All right. This is an integral. Okay. This is an indefinite integral, and this is a definite integral because you're going from A to B. All right. So that's what we're shooting for. So that's what you got to kind of get. What are we shooting for? Well, let's get started. We know we got to get to velocity. So let's go ahead and take the antiderivative. We don't know from where to where, so let's do this. We're going to figure something out here, though. Minus 2t dt. Now that is going to be simple because that's going to be equal to, now this is v at t, by the way. Alright. Now all you do is add. If there's no constant there, you put a constant beside it. Do not make this hard. Minus 2. Now this is 1. We increase that by 1, and then we divide by that same number. Okay, if this is n goes down here. Okay, 2 over 2 divide out, so 2 over 2 is 1. So we're left with 1t squared, or just plain t squared. I'll need all the room I can get. Now remember, you do not forget to put a plus c. So what we have here, ladies and gentlemen, is v at t is equal to 3t minus t squared plus c. Man, oh man, the last time I did this problem, I put a plus sign here, and I did everything right, except this is a minus sign, so you got to watch your signs, even at this level. Now, I already know that v at 1 is 10, so here's what we're going to do. We're going to say v at 1 is going to be 3. That's when we have that. If we didn't have that, we couldn't find the value of c. So that's what we're trying to do. We're trying to get this value of c. So what you got to do is, if you don't have a definite integral, you're going to have a c, a constant c at the end. Okay? You know, so anyway. Then, if you already know what this is, then it's not v at 10 is 1, it's v at 1 is 10. Alright, so here we go. V at 1, which is 10, is equal to 3 times 1 is 3, minus 1 plus c. So 10 is equal to 2 plus c. Then I subtract 2 on both sides, and I have c is equal to 10 minus 2 is 8. So up here, I'm going to have v at t, now, without the 1 there, is equal to 3t minus t squared plus 8. That's what you're looking for. Now you have this completed. You cannot ignore, you can't just say 3t minus t squared. Some people ignore that. You got to have a constant here at the end, plus c. If there's not a definite integral, it's always going to be plus c. And you got to have something to help you out, like this velocity is 10 at t equals 1, otherwise we can't do this any further. Alright, now we got to get to we got the velocity. Now we got to take the antiderivative of velocity, but we have a definite integral here, and we are going from 1 to 5. Now b at t dt, which is this here, 3t minus t squared plus 8 dt. Nice. Again, the rule is the same way. So this now is s at t. That's what that is. Alright, so now we have 3, well actually we don't, let's not worry about putting that down here. Let's just keep going. Equals 3 times 1. Alright, so yeah, 3 to the t. Now I've got to add 1 to that, so that makes that squared over 2, like that. Add 1. I already have a 1 here, so 1 plus 1 is 2. So 2, and then put the 2 down here. Add 1 to the 2, you get a 3. Put the 3 down here, and then plus 8. And then if you got a constant, don't forget to put the t. Don't leave the 8 right here. You don't have a plus c here. You do have a definite interval from 1 to 5. Okay. Well, let's flip this board over so we can finish this problem. I may have to look at it time and again to get it right. So you can put this in parentheses if you want to. There you go, like that. Alright, now this is we're going to apply the fundamental theorem of the calculus, and then we're going to get it from here. But notice first of all, before I flip this over, that I had to realize I had to do a definite integral, or I had to do an indefinite integral. Okay, which is called an antiderivative. Okay. All right, so we did that. We got a constant at the end. I want to say that's called a constant of variation, I think. And then you find that constant c, and now you've got it. So that's what you had to do. You had to use this information here to find c. Sometimes you got to know what this is for. When you see this, oh, I'm looking for c. Alright? And so eventually you'll learn to do that. Then you got your problem. Now you can keep on going right here. So let's flip this over and let's finish this out, and then we'll see what S5 minus S1 is. Okay? Alright, so let's do that. Let's flip it over. And I gotta move it forward. Sorry about the inconvenience. Now look here, buddy. You're not gonna do me this way. Flip it up. Oh, come on. Come on. There we go. Now, okay, so I might have to, for the time being, I'm not gonna push it all the way back, but I'm gonna have a little room back here. Now let's put it down right here. Alright, so now we have 3t over 2, I think. Not squared. 3t over 2 minus, I want to say that's what it is, 3t over 2 minus t cubed over 3 minus t cubed over 3 t cubed over 3 plus 8t, and we're going to carry that from 1 to 5. I do believe it is from 1 to 5. Alright. 3t, is it squared? Did I square that? It was squared. Wow. Yeah, it was squared. Okay, so it is squared. Well, I don't know why I would have a 2 if I didn't have a 2 up here. So that makes sense now. Okay, that makes sense. Now let's move it back. Okay. Alright, we got it going now, folks. Now that's equal to. Now we got to do it is going to be like S at 5 minus S at 1. Okay. Alright, so that's the fundamental theorem of the calculus. It's part A or part B or whatever you want to say. Anyway, one of those two parts of the fundamental theorem of the calculus. So let's do that. Alright, so 3, put it, yeah, I'll do it this way. 3 times 5 squared. That looks good because I remember that was the answer. Plus 5 cubed over 3 plus 8 times 5. Alright. I am sure of that. Alright, now we gotta keep going with the minus sign. Oh boy, where did I put it? Let's put it over here. Minus. Okay, we're moving everything over here. Okay. I should have spread that out. Okay, it doesn't matter. Now it's 3 times 1 squared over 2 minus 1 cubed over 3 plus 8 times 1. And there it is. There's your fundamental theorem of the calculus. If you're dealing with AP Calculus AB, this may be all you got to do, but I'm going to go ahead and find the answer anyway. Alright, remember 5 squared first, so 5 squared is 25 times 3, which is 75, so 75 over 2 minus, okay, 5 cubed is 125, so minus 125 over 3 plus 40. I'm thinking that is correct. And then minus sign. Alright. Anytime you put 1 squared is 1. This is just 3 halves. This is 1 cubed is 1, so 1/3 plus 8. Alright, there we go. It's looking a whole lot better, isn't it, guys? Okay, so there we go. 75 over 2 minus 125 over 3 plus 40 minus, let's just distribute in the minus sign, 3 halves plus 1/3 minus 8. Some reason or another, I don't know what I'm thinking, just somehow or another it's looking good. I think let's see, let's combine 75 over 2 minus 3 over 2. 75 minus 3 is 72 over 2. That's good, because I know that that's 36. And then, so we got these two. Negative 125, this is negative 124. That's good. And 40 minus 8 is 32. Yeah. Looks good to me. Now let's see what we get here. We got a common denominator of 6, so let's multiply by 3. Well, now 72 over 2 is 36. That's right. Minus 124 over 3. 3 won't go into that evenly, unfortunately. Plus 32. Alright, so now we're getting close. I know it's going to be right. 68. 68, I think that's right, isn't it? 68 minus 124 over 3. Alright, so 3/8 are 24. Let's just put it over here. 3 times 8 is 24. 3 times 6 is 18, 19, 20, 21. So we have that all over 3, because I just multiplied by 3, didn't I? multiply by 3, multiply by 3. That's all I did there. Minus 124, all divided by 3. Now that's going to get us something over 3. 4 minus 4 is 0. That's looking really good. 11 minus 2. No. Supposed to be 80, not 90. And let me see here. 3 8s are 24, 3 6s are 18, 19, 20. 204. Ah, that's more like it. Alright. You can't, I knew something was going on here. Now 12 minus 2, 10 minus 2 is 8. And then of course that just leaves us 1 minus 1 is 0. So 80 over 3. So this is 80 over 3. And that is correct. Now, we found, what units would we put here, by the way? Velocity, we started off with acceleration, which is, if we had feet per second. So this will be feet per second squared would be acceleration. Velocity would be feet per second. What would this be? Now remember, this is distance, S, so that's just feet. So you start off with feet per second squared to feet per second. This would just be feet. But we don't have units, so we don't put any units there. So that's the answer right there, 80 over 3. Believe it or not, this was a a multiple choice question. So, wow. Anyway, there it is. Alright, anyway, I just wanted to give you an idea of how to integrate, plus also the idea of uniform motion, going from acceleration to velocity to distance. So anyway, KP the Math G signing off. Ladies and gentlemen, please subscribe if you haven't done so. I do like to see subscribers, but if you don't subscribe, okay. I would like to see a comment, but if you don't comment, okay. And hit that like button. If you don't do anything else, hit that like button. Anyway, it's not about me though. Whether you do any of those or not, it is about you, and it's about your understanding here of what to do. Okay, and I trust that I have made it clear, and if I haven't, please let me know in a comment, and I will explain it again to you. All right, KP the Math G signing off. Ladies and gentlemen, have a great day.